Good. Close. So it's not going to be 31. Good try. Because remember, it's an inscribed angle. Good, good, good. It's going to be twice the amount. Right. So arc FJ is 62 degrees. Well, why is that important? Because look at angle H. It's going to the same, it intercepts the same exact arc, doesn't it? Look at angle H and angle G. They both intercept the same exact arcs. Well, if that's true, then they must be the same measure by law, right? Because angle H is going to be half of 62, which of course is 31 degrees. So I can mark that 31 degrees. All right. Now what's arc? So next one, it says, what's the measurement of arc FJ? Well, we already calculated that, right? For the previous problem, right? So that's 62 degrees. Next angle is, our next question is, what's the measurement of angle HKF? So let's find that. Let me change colors so it's a little bit easier to see. So HKF is this angle right here. Notice that what shape this is right in here, right? That is a triangle. And we definitely know that what? The three angles on the inside of a triangle always add up to be 180 degrees. And you can see that inside of that triangle, we already have two angle measures, 31 and 45. So let's add those together and then just subtract it from 180. And that's going to give us that missing angle. So that gives me 76. And if I do 180 minus 76, that's going to give me 104 degrees. So that's the measure of angle. It's kind of small, just do that, draw an arrow, 104 degrees. Finally, it says, what is the value of X? Okay, well, we're going to need the angle that we just found. So a lot of kids will say, I'm going to erase the rest of this. So it's just getting a little bit messy for me. It bugs me, sorry. That I'm going to mark that 104 because that's what we just found. A lot of kids will say that, and we have that to be 62 degrees. You'll say that X is 62 degrees. Okay, that is not correct. You're thinking it's probably 62 degrees because it looks like a central angle. Okay, but nowhere in this problem did they say that K is the center of the circle. Okay, so it doesn't say, it could be the center of the circle, I don't know, but we can't just assume that it's the center of the circle. It doesn't say it anywhere in the problem. So therefore, I can't say that X is the same as that arc, 62. In fact, what we should do is look at that straight angle theorem that we were talking about a couple minutes ago, right? A straight line is 180 degrees, right? So if that's 104, no, it's not half, it's not 31, because remember, that's only for inscribed angles, right? This one down here is 31 because it intercepts that arc, right? So it's not 31 either. It actually doesn't have anything to do with that arc, okay? So it's a straight line, and you can see this is 104, and this is 76 degrees right here, right? Why is it 76? Because when you add them together, you get 180 degrees. A straight line is 180 degrees. You guys give me like 10 seconds. I'll be right back. Okay, I'm back. Sorry. So 140, my point is that this is 104 degrees, right? X is the other angle that makes up the straight line, so it must be 76 degrees. Why? Because they add up to be 180. So that's 76 degrees, therefore proving that what? That's not a central angle, because if it was a central angle, they would have to be the same, but they're not the same. So that was my point. Okay, let's keep going. We got 10 more minutes here, so let's try to move a little bit quicker. If you guys have questions, let me know. 24. If AC is the diameter, then what is the measure of angle arc AC? Okay, it's important. AC is the diameter, right? So arc AC, if you look, that looks like what? Doesn't that just connect the diameter? So that would mean that that's half of the circle, right? So half of a circle is 180 degrees. That's what that arc is. All right, next one, what's the measurement of angle ACB? So angle ACB is right here. Okay, so let's look at that one. So the first thing I'm going to see is, like we said in the beginning, AC is a diameter. Well, if AC is a diameter, that means, notice how that's the hypotenuse of this triangle. Sorry, not a very straight line there. There we go, a little bit better. That means that this must be a right angle. So we talked about that in previous lessons, that if you have a diameter in a circle and it's the hypotenuse of a triangle, it must be a right triangle. So this is a 90-degree angle. Well, if that's 56 degrees, well, then I can figure out what that angle is, right? Because I know two angles on the inside of a triangle. So I'm just going to add 90 plus 56 and then just subtract it from 180. And that's going to give me 34 degrees if I do that. So that's going to be 34 degrees, angle ACB. All right, now arc AB, let me erase this a little bit so it's a little bit more clear. There we go, so that's 34. If I look at arc AB up here, that's just this arc right here. Well, the angle that intercepts that arc is that 34-degree angle that we just figured out. So then what is the measurement of that arc AB gonna be? Why don't you guys type it in? So again, 34 degrees. What's that intercepted arc gonna be, arc AB? Good, and if you guys want, you can send me private messages too if you don't want it to like show up. Or if you don't care, I'm cool with that too. Good job, 68, all of you. All nice, good. Coming in, lots of it. Nice job, 68 degrees. Yeah, you're right, 34 times 2, right? Because it's twice the amount of that inscribed angle, right? So 68 degrees is that arc. Okay, that does it for that one. Let's take a look at what we got next. 26, I think we can probably do 26 and 28. And then maybe another one if we have time, but let's look at 26. Looks like we have a circle and an inscribed quadrilateral, 4 sides. It says, what's the measurement of angle R? Okay, so remember that theorem, we actually went over this theorem before we even got out of school, was that the opposite angles inside of an inscribed quadrilateral will always be equal to 180. They're supplementary, right? So they want this angle R, right? Well, its opposite angle is 86. So that means that angle R plus 86 degrees must equal 180 degrees. So if all we have to do is just subtract 86 from 180, right? So 180 minus 86 is 94 degrees. So let's mark that 94. And then the same is true for angle S, right? 109 and angle S have to add up to be 180. So 180 minus 109 is 71, I believe. Correct me if I'm wrong. I'm pretty sure it's 71 degrees. So it's just using that theorem that you guys learned, that what opposite angles in an inscribed quadrilateral are supplementary. Like supplementary just means they add up to be 180. Let's keep going. What's the measurement of arc RWT? So let's mark arc RWT here. Grab some. So arc RWT is from here all the way to there, right? What's the measurement of that arc? Okay, let me ask you guys a question. What angle intercepts that arc? Can you guys tell me? What angle intercepts that arc RWT? Good, Elizabeth. Nice job. If I just go straight from the endpoints to the angle, you guys can see, do you guys see angle S? Hopefully you can see it's angle S, right? Well, the relationship between the arc and that angle, remember angle S is an inscribed angle. So that arc is going to be twice the amount. So all I need to do is just calculate 71 times 2 to give me that arc measure, which is 142 degrees. Okay, let's keep going. 28. I believe this is a trig question, if I'm not mistaken, but let's check it out. It says, if KL is a diameter, label the right angle. Okay, so we were just talking about this, right? If that's a diameter, that means that that's the hypotenuse of the triangle, which means that this has to be a right angle, right? That's a right triangle. So that's what it means when it says label the right angle. And then it says, what's the measurement of arc LM? Okay, so that's this arc right here. So if I'm going to figure out the measurement of that arc, oops, I'm going to have to figure out what the measurement of angle K is, because angle K intercepts that arc. So this actually is not a trig question. I thought it might be, but it's not. Because you can see that if that's 57 and that's 90 degrees, we can easily figure out what that missing angle is right there, right? So I just need to take 90 plus 57 and then just subtract that from 180. So that's 147 added together. And if I do 180 minus that, 33 degrees, right? Well, that's not my answer, remember, because that just tells me what that angle is. That means that that's 33 degrees. That's a right angle. So then arc LM, angle K is an inscribed angle, so it's twice the amount. So that would make that arc 66 degrees because it's just 33 times 2. Okay, let's move on. Let's make this last one. Let me find it. We'll make this the last one for today because we're getting right on 30 minutes right here. Okay. Oh, this is a pretty simple one. So it says ML and LN are tangent to the circle P, label the right angles. Well, we know from previous lessons that when a radius and a tangent line meet, they must make a 90-degree angle, always. Here's another radius here that meets a tangent line, so that must also be a right angle. So now I have 3 of the 4 measurements on the inside of the quadrilateral. I have 90, I have 90, and I have 31. So the missing one, okay, they must all add up to be 360 because it's a quadrilateral. So if I add those all up, why don't you guys do that in your calculator real quick? 90 plus 90 plus 31. You guys should be getting 211 degrees, and then the missing angle is just going to be minus 360. So 360 minus that amount gives me 149 degrees. So that tells me that that central angle there, which is the question, measurement of angle MPA, is 149 degrees. Last question, what is the measurement of angle MON? Okay, oh, I'm sorry, not angle, arc MON. All right, let me clear this off a little bit. Let's remember that that central angle was 149, right? So that was 149. Well, if that's 149, that means that this arc is 149, right? And then hopefully you guys know that so the measurement of this arc right here is 149 degrees, right? How many degrees is a full circle? I did not mean to do that. 1 second. So that is 149 degrees. A full circle is 360 degrees all the way around, right? Well, if we already know that that portion is 149, then I'm just going to do 360 degrees minus the 149 that we already know, and that gives me the measurement of arc MON, right? Let's punch that in, 360 minus 149, and we get 211 degrees. That's the measurement of